Hi, this is the third and last part concerning this series about this compass gyro indicator from Sperry. Today we will inject a second harmonic on the input of the slaving amplifier here, and we will see the rotation of the compass card. The precession is a slow process. There is a rotation of 60 degrees of the compass card during about 15 minutes. So I will record the variation in one direction and in another one during 15 minutes each, and I will accelerate the video at the end. This will be the first part of this video. In the second part, I will connect a compass to the input of the slaving control transformer here. The compass will be this one. I assume this thing works, there is no problem, and I can feel inside the suspension of the Fluggate sensors. This is the setup for the first test. The function generator on the left has two outputs. The output on the left is at 400 Hz. This one, it is used to supply the power amplifier, which is in another room. The output of the amplifier is fed to this transformer, which gives the 115 volts AC, which is the supply of this transformer between A and C here. The second output on the right is used to simulate the compass signal. So this signal at 800 Hz is fed to the primary side of this transformer. On the oscilloscope, we can see these two signals. In yellow we have the reference signal, which is this signal here. It is a sine signal at 800 Hz. It is provided using a bandpass filter here, which is set to 800 Hz, and it uses the 800 Hz full wave rectifying, which is at this point here. This coil permits to have a decoupling in order to have an AC signal, and the input of the amplifier is a signal in green, so I can adjust the phase of this signal. Okay, so I can change the phase. So I will turn on the gyro. I have placed a switch in series here, and normally we should have a rotation of the compass card depending on the phase between the reference signal and the input of the amplifier. So I will make a zoom on the compass card because the rotation due to the precession is a slow process, because actually we need to compensate the drift of the gyroscope, which is itself very small. So first we will see in real time, and after I will accelerate the video. I will try to record 10 or 15 minutes in order to have something like 40 or 60 degrees variation of the compass card in one direction and after in the other one. For the moment the signals are out of phase. Let's turn on the gyro. You can see the rotation of the compass card clockwise. Okay, so I will change the direction. Okay, so now the signals are in phase, and normally the precession should be done in the reverse direction. Okay, so we'll stop there for this test. I will turn off the gyro. The next step will be to connect the compass to the input of the slave control transformer. So for that purpose, we can notice that the primary side of this transformer has also an intermediate point here. So this voltage is, I think, 26 volts AC. So I think that this voltage is used for the excitation coil of the compass. Actually, the phase between the excitation coil of the compass and the reference signal here is important. So using a part of the primary side here as the excitation voltage permits to have a fixed phase between the excitation coil of the compass and the second harmonic, which is fed to the control transformer here. I will try also to connect this repeater. This is an ADF indicator. There is only a synchro inside, so I will use one of the two synchro outputs which are available on the rear connector of this indicator. First, I will try to figure out the pinout of this compass. We should have three identical resistances between three terminals. Okay, so there is a resistance of 14 ohms here, 28. Okay, so we have three terminals here with 28 ohms between each pair of terminals. So these terminals are probably the terminals of the floodgate sensors 5, 6 and 7. Okay. There is a resistance of 14 ohms, half the value. Okay, so one coil is separated in two half coils, so this is strange. I don't know why. So this is terminal 8, which is the middle point of 6 and 7. Okay, so we have a resistance of 160 ohms between 10 and 11. Okay, we have 134 ohms, 11, 12, 13 and 14. So we have found effectively the coils of the floodgates, but I have two other coils, one with 160 ohms and the second one with 134 ohms. One of these two coils is the excitation coil. So I will inject voltage and I will measure the current with an oscilloscope, and we will see if one of these two coils saturates. I have connected the amplifier to these two terminals here. There is a shunt in series, and we can see the current on the oscilloscope across the 1 ohm shunt resistor. So we can start to connect these two terminals to the first coil between terminals 10 and 11. Okay, so we have something which is not linear, but it is not a saturable coil. So let's try the second one. The second one is between terminals 13 and 14. Okay, the current is much lower. So let's increase the voltage. Okay, so this is effectively a saturable inductor. So this is obviously the excitation coil. So we can see the saturation of the coil at this point here. There is a sensitivity of 200 millivolts per division, but I am not sure if the probe is activated. Yes, okay, so this is much lower. There is a sensitivity of 20 millivolts per division, that is to say 20 milliampere per division. So the coil saturates with a current of 20 milliamps approximately. I don't know if the second coil is used for the compensation of the magnetic field. Normally we should find two coils, one for each axis. Anyway, I will reinstall the cover of this compass indicator, and we will see if the indicator can be synchronized with the compass. I have connected this indicator to the compass on the right here. So this thing is stabilized since 1 hour now. We will test the compass synchronization. So first I will move the compass, so there will be a change on the compass card, and after a while, normally the compass should retrieve the original position, which is defined by the compass. I will test also that if one rotates the compass, there will be a rotation of the compass card. So the first test is to rotate this indicator. Okay. And after a while, normally, the compass card should retrieve the position 315 degrees. As you can see, the compass card has recovered the previous position, 315 degrees. So now I will rotate the compass 90 degrees, and we will see if the compass will find the new position. It should be something like that. Okay, the compass card seems stabilized now. So you can see that the rotation is not exactly 90 degrees, but anyway, I didn't rotate exactly 90 degrees, and in the lab there are also some parasitic magnetic sources. Anyway, this instrument seems working. The gyroscope permits to know the orientation when there is a quick change on the orientation of the aircraft. And there is a very slow synchronization to the magnetic north using the compass. We have tested, I think, all features of this instrument except the synchro output. When I will have a compass repeater, we'll be able to test this feature also. Thanks for watching, and see you next time for another instrument. Bye bye.